Venn diagrams are a great way of visualizing two-way data or the data in two-way data tables. They're especially helpful when we have the kind of data that we can classify as both, neither, or one or the other. So if we have categories of items where some items have one characteristic, other items have another characteristic, some have both characteristics, and some have neither characteristic, Venn diagrams are extremely useful. So let's look at an example. We're going to pretend for a second that we are baking Christmas cookies for our family. So we go ahead and bake a bunch of cookies, and it looks like we have, 4 cookies across and 4 cookies down. So we've baked 16 Christmas cookies. And we're not really too organized with our baking. So we decide that we're going to put frosting on some of them and sprinkles on some of them. And we kind of do this haphazardly. We're going to go ahead and say that we decided to frost these ones. So we dipped some of them in red frosting, of course, because it's Christmas. And so we did some of these randomly with frosting. Then we decide we want to add white sprinkles, and we're going to go ahead and put white sprinkles on these ones. So as you can see, we're kind of all over the place. We have some cookies that have neither frosting nor sprinkles. Then we have some cookies that have just red frosting. It's the sugar cookie, we dipped it in red frosting, but then we stopped there. Then we have some cookies that have just the white sprinkles, so we didn't dip them in frosting, but then we put sprinkles on them. And then some of the cookies we decided to both dip in red frosting and then cover in sprinkles. So on the one hand, we're a little bit disorganized. On the other hand, our cookies are looking pretty good. What we want to do is organize this data, organize our cookies into a two-way table, of course. So here's what that would look like. We would set up a two-way table where we say down one side, either frosting or no frosting. Did we apply frosting or did we not apply frosting? And then across the top, sprinkles or no sprinkles. So we want to say the ones we put sprinkles on, the ones we didn't put sprinkles on. This then gives us all combinations. Because if we look at this box here, this box represents all of the cookies that have frosting and sprinkles. And so we can see that we got here 1, 2, 3, 4 cookies with frosting and sprinkles, so we put that in there. Then we have here in the first column, second row, all of the cookies that have no frosting but did get sprinkles. So there's no red frosting, but they did get the white sprinkles, and we can see that we have here 1, 2, 3 of those cookies that have no frosting but do have white sprinkles. So we put the 3 there. Then we look at the second column, first row, because we're going through each cell in our body here. And we can see that this cell represents frosting but no sprinkles. So we have the red frosting but no white sprinkles. And that would be 1, 2, 3, 4, 5 of our cookies that have frosting and no sprinkles. And then finally, the last cell, which indicates cookies that have no frosting and no sprinkles. Those are going to be our plain sugar cookies that got nothing. So this cookie got nothing. 1, 2, 3, 4 cookies that didn't get frosting or sprinkles, so we put a 4 there. Now we could have just left our table that way, but we can also include totals across the bottom and down the right-hand side. So we can see that if we add up the column, we know that there are 7 cookies with sprinkles, and we can see that that's true. We have 1, 2, 3, 4, 5, 6, 7 with sprinkles, 9 cookies with no sprinkles when we add up the second column. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 9 cookies with frosting when we add across the top row. So 4 plus 5 is 9. 9 cookies that have frosting. So 9 cookies that have red frosting. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then adding across the second row, 7 cookies that have no frosting. So 7 cookies without the red frosting. 1, 2, 3, 4, 5, 6, 7. And we do in fact get 7. And then the total of both the column and the row, which should be the same both ways, 16, and we know that we do have 16 cookies because we have 4 cookies across by 4 cookies down is 16 total cookies. So this is our two-way table representing our sugar cookies. Now we want to see how to translate a two-way table into a Venn diagram. So here's how you build a Venn diagram. The first thing you want to do is draw a box. And I made mine the color of sugar cookies because this box in a Venn diagram, it's always going to represent your whole universe of data, all of the data that you have. So here we have all our data in a two-way table, or all of our data in sugar cookies. We want to make sure we get all of our data represented somewhere inside of this box. So this is our entire sugar cookie universe. Now in our two-way table here, we put frosting or no frosting and sprinkles or no sprinkles, which means that in a Venn diagram, we want to draw a circle for each of those decisions. So we want to draw one circle for frosting, one circle for sprinkles. So we'll go ahead and draw a frosting circle in red to match our frosting. And we don't have to, but we can go ahead and label that the frosting circle. And then we want to go ahead and draw a circle for sprinkles. And since our sprinkles are white, we'll draw a white circle, and we'll go ahead and call this our sprinkles circle. Now here's what a Venn diagram does. It gives us 4 pieces of area. The first piece of area is inside both circles. It's this piece in the center right here. And this piece in the center is both inside the sprinkles circle and it's inside the frosting circle. So it's inside both. So in our example, it represents all the cookies that have frosting and sprinkles because it's inside frosting and inside sprinkles. So how many cookies do we have with frosting and sprinkles? Well, frosting and sprinkles is this cell right here, 4 cookies. So we'll go ahead and put 4 in that piece of area. Then we have this piece of area, which is inside the frosting circle, and this piece of area, which is inside the sprinkles circle. Those are the next 2. So this one right here, it's inside the frosting circle, but it's outside of the sprinkles circle. So what that means is that this piece of area right here represents the cookies that do have frosting, because we're inside the frosting circle, but do not have sprinkles, because we're outside the sprinkles circle. So how many cookies have frosting but do not have sprinkles? Well, frosting would be the first row. No sprinkles would be the second column. So that's 5 cookies. So we can go ahead and put a 5 here. Now this piece of area, it's the exact opposite scenario. In this piece of area, we're inside the sprinkles circle. So this is going to represent cookies that do have sprinkles. But we're outside the frosting circle. This is the boundary here of the frosting circle. We're outside of it. So this is going to be sprinkles, but no frosting. We're not inside the frosting circle. So how many cookies have sprinkles but no frosting? Well, here's sprinkles in the first column. No frosting is in the second row. That's 3 cookies. So we put a 3 right there. And then the last piece of area in our Venn diagram is outside of both circles, just the area here around the outside that's still inside of our rectangle, which remember is the universe of all of our cookies. So how many of our cookies do we have that do not have frosting, since we're not inside the frosting circle, and do not have sprinkles, since we're also outside the sprinkle circle? So how many cookies with no frosting and no sprinkles? In other words, neither. Well, no frosting is the second row here. No sprinkles is the second column. We can see right here where they intersect. There are 4 cookies with no frosting and no sprinkles. So we go ahead and write a 4 outside of both circles. And we could have written that up here or here in any of the corners, anywhere outside both circles. But this 4 represents neither. So again, in the middle here, we have both. On the outside, we have neither. And then in these areas, we have here frosting but no sprinkles. And here we have sprinkles but no frosting. Notice too that the numbers we filled in our Venn diagram were the ones from the body of our two-way table. And that's always going to be the case when you have a two-way table and you want to express that or visualize it in a Venn diagram. You want to take all of the values that are in the body in the middle of your table and make sure that those get placed into the Venn diagram. And in order to build the Venn diagram, you can always follow the same steps we did, where you draw a rectangle, you draw two circles that are overlapping, so you get this overlapping area, and then you just fill in both this one but not the other one, this one but not the other one, and then neither on the outside. Notice too that when we're reading this Venn diagram, we can see the totals that were in our two-way table. So for example, if we want to know from the Venn diagram the total number of cookies that have frosting, the total number of cookies with frosting is 9. From the Venn diagram, we can see that by looking at all of the numbers that fall anywhere inside the frosting circle. So if I look at this entire frosting circle, the numbers I have inside of it are 5 and 4. They add up to 9, so I know that there are 9 total cookies with frosting. If I want to see the total number of cookies that have sprinkles, that's 7. Well, I just look at all of the numbers that fall inside of my sprinkles circle. That's 4 and 3. The 4 and the 3 are both somewhere inside of my sprinkles circle. So 4 plus 3 is 7, and I can say that there are 7 total cookies with sprinkles. To get my total for no frosting of 7, I just want to add up everything that's outside of the frosting circle. So I know that everything inside of the frosting circle is 5 and 4. These have frosting on them. I ignore those. All of the numbers in my Venn diagram that are outside of the frosting circle are the 3 here and the 4 here. So there are 7 cookies outside of the frosting circle, which means there are 7 cookies with no frosting, which matches our table. And then same thing here for cookies with no sprinkles. I know that 4 and 3 are both inside my sprinkles circle. They have sprinkles on them. I ignore them. But all of the numbers that are completely outside of my sprinkles circle are the 5 here and the 4 here. 5 plus 4 is 9. There are 9 total cookies that have no sprinkles, which is what I see in the two-way table. And then I can even get my total number of cookies, 16 here, from my Venn diagram simply by adding up all of the numbers together. So I have 5, 4, 3, and 4. Those are all of the cookies in my Venn diagram. So 5 plus 4 is 9, plus 3 is 12, plus 4 is 16. So I can see the total number of cookies that I have. So just remember that Venn diagrams are especially great for expressing data when you have two questions and you could kind of answer yes or no to both of them. So here we have the question of sprinkles. And we answered either yes, sprinkles, or no sprinkles. And then here we had the question of frosting. And we either answered yes, frosting, or no frosting. So when you have data that you can sort of think of that way, there's these two kinds of categories that your data items can fall into. You can make your two-way table this way with frosting or no frosting and sprinkles or no sprinkles. And then you're categorizing each item that you have into one of those boxes. You could look at every item and sort of tally it up. You could say this one is frosting but no sprinkles, so it goes in the frosting and no sprinkles, and you could sort of put a tally there. This one is both frosting and sprinkles, so you could get frosting and sprinkles, put a tally there. And you could just keep going, tallying up your items until you get totals here, and you can see that you have 4 cookies here with both frosting and sprinkles, or 5 cookies with frosting but no sprinkles. Once you get that body of your two-way data table built, then you can create these totals if you want to, and you can express all of the data from your two-way data table in a Venn diagram like this one.